Hi, welcome to all my channel. Today we'll discuss about low pass filter design. This is one of the very important topic under the subject digital signal processing. Before we start our actual design procedure, let us see the specifications of the low pass filter. Here I'll show you the diagram representation of low pass filter response in terms of gain and attenuation. Here the first diagram shows that here this is the response of the low pass filter in terms of a gain versus frequency. Here I can show that on y-axis I'll be taking HA of omega, which is the gain of a low pass filter, and on x-axis I'll be taking the frequencies omega, which is measured in radians per second. And as all of you know, the low pass filter is characterized by upper cutoff frequency. It will allow all the frequencies up to the maximum cutoff frequency. Here it will show you the omega 1, which is the passband frequency in radians per second, corresponding to the 3 dB gain. Here the graph shows that from 0 to omega 1, which is called as a passband of the low pass filter, that means all the frequencies which lie in between 0 to omega 1 will allow, and from omega 1 to omega 1, which is called as a transition band, and omega 2 towards the maximum value, which is the stop band, indicates that the frequencies which lie above omega 2 are completely stopped or eliminated. And here I'll show you another graph which shows that the attenuation versus the frequency. Attenuation is nothing but reciprocal of the gain. The graph shows that, and at omega equal to 0, its attenuation is also 0. As the frequency is going to be increases, the attenuation constant is also going to be increases. Here I'll explain a few of the important terms with respect to this diagram. And here let omega 1, which is nothing but a passband frequency, which is measured in radians per second, omega 2 stop band frequency in radians per second, and the corresponding gain A1, which is nothing but magnitude of HA of omega when omega equal to omega 1, and the another gain A2, which is equal to the magnitude of HA of omega when omega equal to omega 2, and the corresponding attenuation constant has to be measured. I told you already, attenuation constant is nothing but reciprocal of the gain. Alpha 1 corresponds to the gain A1, which is equal to 1 by A1, and 1 by magnitude of HA of omega and omega equal to omega 1. And similarly, the alpha 2, which is 1 over A2, and 1 over magnitude of HA of omega, as omega is equal to omega 2. Thank you for watching my channel.